Problem set. Question number 1 says, how would you prepare a 2.8% weight volume solution of sodium chloride from solid and whatever else you need? So if you want a 2.8% weight volume solution, by definition that's defined as X, the number of grams of solute you want to use, and you want to make 500 milliliters of solution, and 100 is part of the equation. When you solve for that, X becomes 14, and X is 14 grams. So what you would want to do is get a 500 milliliter flask, put your 14 grams of sodium chloride in there, filled to the line with water, and it would be a 2.8% solution. That's number 1. Number 2 says 50 milliliters of methanol are dissolved to make 250 milliliters of solution. And the density of methanol is 0.79. And that's grams per milliliter. 2 questions. What's the percent volume? And what's the percent weight volume? So what we want to do there is start with the easy one, because you're given the volume of solute and you know the volume of solution. So the volume percent is simply 50 over 250 times 100, and that gives you 20% as your weight volume. We can also take our 50 milliliters of methanol and use the density, which is 0.79 grams per milliliter. And converting that 50 milliliters into grams will give us 39.5. And that is again using the density, which we need milliliters on the bottom and grams on top to change volume into grams. And so the 0.79 goes with the grams. And once we have our mass of solute, then we can get to our weight volume by just taking the 39.5 grams, dividing by the solution volume, multiplying by 100, and that gives us 15.8% weight volume, which will round off to 16% because the original given was 2 sig figs. Number 3 asks you for what's the molarity in number 1. So if we go back to number 1, and we realize we're looking for molarity, moles over liters, we're going to take the mass, 14 grams, divide by the formula weight of sodium chloride, and then divide all that by the liters, and that's going to give us 0.48 molar sodium chloride. Number 4, as for the molarity in number 2, and again, to get molarity, starting with that formula, we're going to get to our moles by taking the grams, 39.5, divide by the liter, divide by the formula weight of methanol, which is 32. That gives you moles. And then divide all that by the liters of solution. And that mathematics gets us to 4.9 molar in methanol. Number 5 says, how much 12 molar HCl would you need to make 500 milliliters of 2 molar? So whenever you're going from 12 to 2, that's a more concentrated molarity to a lesser concentrated. So you're using dilution, and in this case we're starting with 12 molar. We need to know how much of it to use to dilute. We're trying to make 2 molar and we're trying to make 500 milliliters. And the mathematics says you should use 83.3 milliliters of the 12 molar. And then you would put it in a 500 milliliter flask and fill to the line with water. And then the resulting molarity would be 2 molar. Number 6 says if we have 75 grams of sodium carbonate dissolved in 250 milliliters of solution, what's the molarity? So molarity is moles over liters. We have 75 grams of sodium carbonate and it has a formula weight of 106. So that will give us moles. And we're putting that in 250 milliliters or 0.250 liters. And so the molarity is 2.83. Number 7 is all about beer. So that can of beer is 1.16 liters in the ethanol concentration. That's the formula of ethanol, is 1.16 molar. And the question is how many grams? So using the molarity formula, and we do that because we know we can convert moles into grams. And the two givens are the molarity and the liters. So we plug in molarity and liters, and that gives us moles of 2.32. And then we can use the formula weight of ethanol, 2.32 times 46, which gives us 106.7 grams of ethanol. And if we want to convert that into milliliters, we take the 106.7 grams, and we need the density, and the units need to be grams on bottom, milliliters on top. And the density of ethanol is 0.80. And so that says we would have 133 milliliters of ethanol in there. That's number 7. Number 8 just says go back to number 1 and calculate your ppms. As an approximation, if you know the percent, you can approximate ppm by just sliding the decimal 4 places over. So 1, 2, 3, 4, and that gives you 28,000 ppms. Number 9 says you're using sodium hydroxide, formula weight of 40 grams per mole, and you're taking 8 grams into 1 liter or 1,000 milliliters. So if you have your solute and your solution amount, that's going to give you 0.80% weight volume. If you want your molarity, which is again moles over liters, we're going to take the 8 divided by 40. That gives us moles. Now we're using 1 liter for our solution, and that gives 0.20 molar. And the ppms, again, we can approximate if we just take 0.8, which is our percent, and slide the decimal over 4 places, and so we're going to have, as an approximation, 8,000 ppms. And lastly, number 10 is another dilution that says if you take 5 milliliters of 2 molar and dilute to 500, what's the new molarity? So if we take 5 milliliters of 2 molar and dilute to 500 milliliters, what's the new molarity? And solving for M2 gives you 0.02 molar.